AC oscillation. Here it is. See, if we have a capacitor and initially the charge in the capacitor is 0, so I'll connect it to DC source. So if you take the, here it is, EMF is E, or you can take V. So the charge in the capacitor, it will be like C into V. So now what I am doing now, I'll take this charged capacitor, I'll connect across the inductor. So C and L, this will forms the LC circuit. So once the capacitor is connected to the battery, it is storing some electrostatic energy. That electrostatic energy is given by Q square by 2C, or you can take Q naught, which means the maximum charge in the capacitor. So now the cycle will start. That means this is the point where time t equal to 0. So once you connect the inductor to the capacitor, so the charge will flow like this. Means the capacitor will discharge the charge. It will discharge the charge. That means the charge reducing from Q naught to some, for example, Q. Meanwhile, once the charge is reducing from Q naught to Q, the current in the inductor increasing from 0 to I. So what is going to happen? As time passes, the electrostatic energy in the capacitor is converting into magnetic energy in the inductor. So this is what oscillation is happening. So what I can say here, it is electrostatic energy in the capacitor is converting into the magnetic energy, and obviously after some time the magnetic energy is again converting into electrostatic energy in the capacitor. So if you see here, the energy in a capacitor is given by Q naught square by 2C, and after some time it is becoming like Q square by 2C. That means here initially we have the maximum value, finally you can reach a 0. So you know that if anything starts from the maximum value, I can start with Q equal to Q naught into cos omega t. So why I am writing this equation means, if anything starts with maximum value, I should start with cos. So what I can get to here, it is current in the inductor is given by dq by dt. So when I take the differentiation for that, q equal to q naught into cos omega t, I'll take that q naught outside, cos omega t differentiation is minus sin omega t, and I should take minus omega, minus q naught into omega into sin omega t, and I'll take that I, here it is minus q naught into sin omega t. I am writing here what is omega. So what exactly the omega here, it is 1 by root LC. So therefore what I can write here, it is now minus q naught by root LC into sin omega t. So what is the energy stored in the inductor is given by of Li square, of Li square. I can write down this one as q naught square by LC into sin square omega t. Now see this point here, LL gets cancelled. Okay, you can write down this one as q naught square by 2C into sin square omega t. This is the energy stored in a inductor. EL I can write. Energy stored in a capacitor. What is energy stored in a capacitor? Q square by 2C. What is the Q in this case now? You can see here Q naught cos square omega t, Q naught square into cos square omega 2 by 2C. So if we check these formulas, energy stored in a capacitor is given by this formula, energy stored in an inductor is given by this. So I am writing that energies, for example, Q naught square into cos square omega by 2C. This is the energy stored in a capacitor, and energy stored in the inductor, which is Q naught square by 2C into sin square omega t, which is the energy stored in inductor. Now try to understand very clear, the total energy in the circuit is given by, if you add this cos plus sin, cos square plus sin square, it will get 1. The total energy in the capacitor is Q naught square by 2C. So what I can understand here, it is total energy in the capacitor is same only, but that energy is fluctuating between capacitor to inductor. What do you mean by the energy is fluctuating between that in between that capacitor and inductor, in the sense energy transformed in the form of electrostatic to magnetic, or magnetic to electrostatic. That means capacitor generally goes with the electrostatic, inductor generally goes with the magnetic energies. Like how the you can see here the energy is oscillating. So what do you mean by that energy is oscillating means, if you take time t equal to 0, capacitor having the more energy, inductor having the zero energy. Therefore, total energy stored in the capacitor. If we take t equal to t by 4, t by 4 means 90 degrees. You can substitute 90 in this first formula, like here. If you substitute here, it is very clear, it will be 0. So in the capacitor, energy will be 0, but in the inductor, you can substitute here theta equal to 90. I'll get the maximum value. So what do you mean from that? From time 0 equal to t by 4, the total energy in the capacitor transferred to the inductor. Now if you take t equal to t by 2, what do you mean by t equal to t by 2? At that time you can substitute the formulas, it is very clear. So substituting the t by 2 in the sense 180 degrees. If you taking that 180 degrees, again I will get the capacitor maximum, but inductor 0. But after t by 2, capacitor will discharge, but what is going to happen? It will charge in a reverse mode. It will charge in a reverse mode. Even inductor also will get the current in the reverse mode. So what do you mean from that? So what I can say here, it is energy is transmitted between the capacitor and the inductor, but first 0 to t by 4 total energy transferred from capacitor to inductor. Again t by 4 to t by 2, again energy in the inductor transferred to the capacitor. After t by 2, the capacitor will charge, but it will charge in a reverse direction. Again t by 2 to t by 4, one more cycle, like at 3t by 4, again capacitor is 0, inductor equal to maximum. And last one at t equal to t, again capacitor is coming to the maximum, and inductor current, inductor energy will be the minimum. This is how the cycle starts. You can check this at t equal to 0 and at t equal to capital T. Capacitor starts with the maximum energy, here also ends with the maximum energy. So this cycle will continue. So it is very clear evidence that energy is oscillating. So I hope you understood the concept of the LC oscillation. Right, you can analyze with the concept of the simple harmonic motion also. What exactly the simple harmonic motion here it is? See, if we have the spring here and if you have the mass here. So first of all, the spring has some energy, you know that, of kx square. Once the spring is hitting this mass, it will get the some kinetic energy, that is given by of mv square. Okay. Now what I am trying to say here it is, this is exactly capacitor and this is actually inductor. That's what I mean. And mass here it is there, na? So like mass, what we have in a current, electricity, inductor. Instead of velocity, what we have in electricity, I square. So actually mass, you know that it will oppose the change in velocity, right? So definitely here also inductor is opposing the current. Okay, that is the reason inductor we can call it as electrical inertia. Here this is mechanical inertia which is opposing the change in velocity, and inductor will oppose the change in the current. So we have that analysis. I will show it in another video. Thanks for watching this video. Thank you.